Welcome to the Maine Science Podcast. I'm Kate Dickerson. Today's episode is a conversation I had with Chuck Donnelly, the CEO of Rock Step Solutions. Chuck has had an incredibly interesting journey, not just to Maine, but also in his professional career. We had a great and fun conversation. Chuck's passion for making data analysis and tools work better for science and scientists is infectious. I loved hearing about all the ways he's figured out his way in the world. Two quick notes before we jump into our conversation. Chuck's audio very occasionally goes out a little. We've tried to account for it in our post-production, but you may still notice it a bit when you listen. And we also talk quite a bit about NIH, that is the National Institutes of Health. I was hoping that you could tell us how you got to Maine, because I know that, like me, you were not lucky enough to be born here, but you made your way here.
Yeah, I guess I'm a transplant for sure. I grew up in New Jersey, and as a kid, we came to Maine on vacation, as so many people do. But my quest for science and learning and exploration took me out west. And so I was in San Francisco, and I was at UC Berkeley. I was working on research at UC Berkeley, but I always had the feeling for I wanted to smell the pine trees and the ocean and just the Maine coast experience. It just never left me from the time I was a kid. So I was always looking for a way to get back here. And believe it or not, the journey here, so I was at UC Berkeley. I had a great job there. I was in the space program there. We can talk more about that. But the reason why I came was because of this tug of Maine. And I was trying to find a way to get back here. And my wife and I were very interested in, we wanted to do something different. I was, almost 40 at the time. And so we bought a restaurant actually in Maine, and and it was a club, had music and had a lot of things that I was very interested in as a hobby. And so we bought it and we moved here. And then I quickly realized that science was really what I was really interested in. And so I started to look around thinking, how can I stay in Maine and continue being in science? It didn't take me long to have that pull from science again, and ended up applying for a job at the Jackson Laboratory as a scientific software engineer. And then once I was there, I quickly moved into what can I do at Jackson Laboratory besides being just a software engineer? Was nothing wrong with that, but I wanted to really grow. So I took classes in molecular genetics, molecular biology, et cetera, and then started a group there called the Computational Sciences Group, and eventually became the director of computational sciences at Jackson Laboratory. And that was really solidified my stay here in Maine.
So your background, I'm not going to let you get away with not talking about space in the restaurant, but your background was in software and IT before you dove into the molecular biology and genetics?
So my degree's in computer science. And while I was so I took that degree, and I became a member of the Space Astrophysics group at UC Berkeley as a software engineer, lead software engineer, on a couple really interesting projects. And one of them was the Search for Extraterrestrial Intelligence, the SETI project, and developing algorithms for signal detection, interference identification, as well as real-time signal processing, building signal processing equipment that went onto telescopes and things like that. And then the other half of my work there was developing software for spaceflight, to be on satellites that were controlling scientific instruments. So I had both, the ground-based astronomy as well as space-based astronomy. And so it was super exciting to be in that world of space sciences. And then I worked on as part of that, I worked on ground control on the space shuttle for one of the missions where we actually put one of our telescopes in the payload bay on the space shuttle.
So those two areas seem really different. Was your work, were they almost different sides of your brain, doing the outer space and then the space shuttle stuff? Do you know what I mean? Like the SETI stuff is really different, what you're trying, from what I understand, from what you're trying to capture. But then the satellite system, it's super applied. You know exactly what you're doing, right?
Yeah, they are very different. Yeah, in the SETI project. I was a co-experimenter and, worked on grants, wrote grants with the team there. And we were developing we didn't know what we were doing. You don't know what you're looking for. You're trying to figure it out. And so you're really figuring out how to engineer the systems for signal processing and all of that. Whereas when I was on the developing spaceflight systems for the telescopes that flew in orbit, those were other scientists' projects. They were building the telescopes, and I was developing the software technology to control those telescopes. Of course, at that time, we were also creating or inventing new technology to actually run in space. So there was a lot of creative work there. It wasn't just program this, but we actually had to figure out how we're going to build this thing. So I was part of those teams. And then on the space shuttle, so we put telescopes into the space shuttle's payload bay, and that's a very highly prescripted, trainings. I literally trained for about an 18-month period before even, before the launch of the mission, and it's very, it's very controlled. Sort of, you're just learning how to run this payload in the back of the space shuttles. In the payload bay, but they also, part of that whole experience is they train you to deal with emergencies and situations where your instrument fails and you have to diagnose it in space and do all of those things. And of course, that's what happened in real life too. So we were successful in bringing the telescope back to life after a failure and went through all of that. So yeah, I guess it's kind of different, but very related.
So both of those things sound like in some ways they totally primed you for running a restaurant, in that everything can be totally thrown up in the air, but there's also pretty strict regimented things that you have to do every day, which is a very strange situation.
The restaurant, I will admit, was something of a midlife crisis. You want to do something down to earth and meaningful. And my wife and I very much connected on cooking. We like to cook together. We took classes at the Culinary Academy, and we decided to do the restaurant. And I'm a musician as well, so it had music. So it was part of the whole thing was music and food, and kind of fulfilled a lot of need. But I'm a really curious scientist, and the restaurant process is very, for me, I was not a real creative artist chef, and for that kind of person, that's going to be a great, palette to paint your art on. But for me, it really wasn't. And so I was more into the engineering of the restaurant, and decided to really go back into science.
So were you close? Were you when you moved here? You said you felt the appeal. You always felt the allure of the coast and the pine trees I've been fortunate enough to live in quite a few different places in the country, and actually spent a year in Ireland, which is the closest I've ever felt to Maine, is when we lived in Ireland. But there's nowhere else that has a coastline that Maine has, or up where we are and up into the beginning parts of Canada. Well, I call it the beginning parts. I'm sure they wouldn't be very okay with that. Right. Were you close enough to that, or is that how you found out about Jack's, I guess, is what I'm asking? Were you close enough to it?
We're in Blue Hill. So
okay.
It was a Left Bank Cafe in Blue Hill, and it was beautiful. It was along the coast. But to be honest with you, when you're running a restaurant, you don't have any time to enjoy the coast. So it's really just working. It was a wonderful experience, though.
So the computational data lab, computational genetics?
Computational science is the general term. And go ahead with your question.
So you said you started that at Jack's. What exactly did that look like once you guys got it up and going, and why did you feel like you had to start that?
So, that's a really great question. So one of the challenges at Jackson Laboratory at that time, this was now going back 1998, I believe, is when I started that. Maybe it was 99. But it's really difficult to find software engineers that love science. It's not impossible. In fact, there's a lot of software engineers that love science, but maybe I'm better off saying that have actually dove into the science more. So when I was at UC Berkeley in Space Astrophysics Group, I was really, really into the physics, right? And I took a lot of courses in physics so that I could work with the scientists with my technology. And at Jackson Lab, I took classes in molecular genetics, and I really wanted to do something bigger at JAX. And there was a real need there for the software engineering skills that I had and the science skills blended. And I was kind of uniquely positioned at the lab at that time to do that. Now there's a whole, that's become a discipline, bioinformatics. That was a discipline back then as well, but it's become much larger. And so but at the time, it was a really kind of an open field for me to go into and create this group that could work with the scientists at the Jackson Laboratory and provide that service to them, because most of the scientists at JAX, they're pure scientists, but they need the technology, the computers, the programming, the development of algorithms, et cetera, to do their research, but they don't have that skill. So my group at JAX had bioinformaticians, software engineers, biologists, biostatisticians, all in one group that could work together to develop really high-end bioinformatics software systems to help solve the problems for the scientists at Jackson Lab.
So would that be everything from analyzing the reams of data to, I'm cheating a little bit because I know what you do now, to keeping track of all the different mouse models and how the experiments are going? I mean, it sounds like it could cover almost anything beyond the actual pure science that the researchers are looking at.
Yeah, so there's kind of, I think of it as two different sort of fields within computational science. One is really the engineering of data. So it's creating databases that can structure data for scientific research, track data for scientific research, help them manage their laboratory processes and workflows. That's sort of an engineering discipline within the science. You need to understand the science, but it's strictly an engineering discipline. And then there's the more the bioinformatics and the computational biology, if you will, where you're taking data. For example, let's say it's a tumor sample and you sequence the DNA in that tumor sample, and then you're trying to figure out what what's driving that tumor, right? There's mutations in that DNA. We want to find those mutations. We want to understand which mutations are causing the tumor, the miscue of the replication of the cells that's creating the tumor. What is going on, and then what therapeutics can be applied to target that mutation or target the pathways that mutation's impacting within the cell. So that would be sort of, it requires a lot of programming knowledge because you're going to be handling lots of data, but it also requires a lot of, you have to be really deep into the science as well. So that's where I sort of see, the two disciplines coming together, the engineering of the data and the science.
So that leads you to the not very small task of just starting your own company to handle this.
Yeah, which is wondering what I was thinking when I did that, but
I have that thought about things I do all the time, if that helps. I know that you've been part of, or Rock Step Solutions has been going on, I'm going to say since 2014, right? I mean,
yes, yeah. So it was grant funded.
So that's what I was going to ask you is first of all, it seems like you're past the true startup phase, or what I would consider the startup phase, and pretty established in what you do. Please correct me if I'm wrong, but if you could explain kind of how do you get from this guy who clearly love learning about all these different sciences and merging it with your expertise. How do you get from that to a startup company that's grant funded? And then maybe we'll talk a little bit more about what it is that you're actually doing with Rock Step Solutions.
Right. Yeah. So it's kind of a journey that you go through, that I went through for sure. So I was at Jackson Lab, a very stable, organization, and really fascinating, interesting science. But also what was happening, what I recognized is that the priorities at NIH were changing. And over time, I was at Jackson Lab for 17 years. And over time, the priorities were changing. And so I recognized this opportunity that NIH was interested in commercialization of, taking science tools like we were building in my group, and how can we commercialize them? And that there's two reasons for that. One is that way NIH doesn't just fund us to build tools, get it off of their budget, if you will. Create a business in the, that can actually create good jobs, but also create a product that advances NIH's goals. So recognizing that some of the stuff that I was doing at JAX actually could be commercialized and actually advance NIH's goals, I went to NIH and said, look, you have a program, that program called the SBIR program. It's the Small Business Innovative Research Grant Program. So I talked to them about that, and I talked to them about this idea. I said, look, there's a big gap in the informatics software solutions for drug discovery and research, preclinical biomedical research. A lot of it's being done with spreadsheets and with old technologies, if you will. And we were right at the cusp where the iPhone was coming out, all the mobile devices, the cloud computing was coming out. There was all this new technology that was not being leveraged yet in this biomedical research area where we were working. So they were excited about it for a couple reasons, economic development, good jobs in Maine specifically. That was Maine's interest in it. And of course, getting it off of their, out of their budget, turn it into something that could be good for the economy as well as good for NIH. And in some way or another, there's always, even though it's commercial and people pay for the product now, people are always paying for it some way or another, right? Everything gets paid for. And so this is just a different way of paying for it, And so NIH was really excited about it. And in 2013, I met with NIH, I drafted this grant proposal, and then I kind of forgot about it, to be honest with you. Like, I'll never get this because the bar is really high. Very few people actually get these awards. And then in 2014, my phone rang and they basically said, you got a really good grant proposal here and we'd like to fund it. It's not quite exactly how it goes, but that's basically get an email with a score, et cetera. And oh my God, I didn't, be careful what you ask for, So I left Jackson Lab at that point, took the grant funding and started the company, but it was only a small amount of money at that point. It was $250,000 or $225,000, I think, which seems like a lot of money, but it's not a lot when you're when you have big goals, big lofty goals. So use that for the first year to build essentially some prototypes of the product, started to develop some partnerships with UCSF and other research organizations, and also started working on the next grant. So the next grant from NIH, the first grant is just to see whether you've got the seed of an idea. The follow-on grant is the one that's $1.5 million, and that's going to actually give you enough cash to build something that's commercializable. And so we got that grant. It was not easy. It took me another year and a half or so from starting to write it to getting funding. We were very nervous, running out of money. Are we going to make this happen? But got that funded, and that's really the starting point where a company started to emerge. A company with employees rather than just a few founders trying to hack away at software. And then that's just the beginning, because that only gets you so far, and then you have to bring in investors and all of the things that you need to do to build a company that's a viable technology company, which is what we're doing now.
So was that second grant time limited, so that, you had to first have only a certain amount of years to spend all the money, but secondly, also then not just time limited, but also kind of show what you had at the end of it?
Yeah, so it's a 2-year grant, so $750,000 a year.
Wow, that is a short grant. Holy cow.
Right. Yep. And it sounds like a long time when you're, on day one, and $750,000 a year sounds like a lot of money, but you really go, with the technology development and all of the costs that go into it and all the trying to build up everything from the technology platform to a marketing and a sales commercial team and a support team. And that money can't be used for marketing or support or sales or anything like that. So you have to find other sources of revenue for that. But yeah, we went through it in 2 years, and then we did get a third grant from NIH, which was a little supplemental award to kind of get us through another, few months, if you will. I think it was another $100,000 or something, got us through another few months while we're raising capital from investors and trying to bring in revenue.
So if I have the time right, you really were able to kick off with a solid project and a real company about 2016, 2017.
Yeah, so by 2017, we had a product and we were selling it, but this is where it gets really, really tricky. So I really, I think it's exciting and I encourage people to do this, but it's not easy. It's not for the faint of heart. So we had a solid product, but what we needed to do is to get into the commercial market. So because the academic market is good, but it's a very price sensitive market, and it's not going to be, you're not going to be able to really develop not easily anyway, a scalable business that investors are interested in just academia. So we had to move into the pharmaceutical industry. So the biotech, pharmaceutical contract research organizations, because that's really where the economy, if you will, of what we're doing is really robust. And that was a big effort. So we had a good product, but it wasn't actually positioned well for the commercial market. It was positioned very well for the academic market.
And by positioned well, you mean designed for that type of lab or that type of work?
Yeah. So it's very similar things they're doing, but it goes from being a small research lab to a very high throughput sort of environment where they're doing a lot of work really fast. There's a whole different sort of persona, if you will, that is using the product. So we partnered with Novartis, and we partnered with the University of California, San Francisco, and then another large public biotech. And we agreed to work together for a period of almost 2 years to develop the next generation product for the commercial market. So now we're talking about 2017, 2018, we started that. We released our product for the commercial market in 2020. And that's really the product that's going to make the company a viable long-term company. So now we're a long way into it. We have an academic market. We're generating some revenue from there, but it's not really enough to move the needle for us, if you will. And what happened in 2020 when we released the product? Of course, everybody knows it was the middle of a pandemic. This is what one of the lessons of being an entrepreneur is like, this is a boxer said this, everybody has a plan until they get punched in the mouth. What are you going to do? We're releasing our product and everybody's fled to the corners, right? And it turns out that our product being in this industry is a robust industry through the pandemic, but getting a company product launched was really hard.
Oh, I can't even imagine, because you're just introducing yourself to the whole world and the whole world had to hunker down, right? So
exactly. And now everybody's moved into the digital realm, right? And so there's a lot of digital noise. Every company, IBM, everybody is doing digital advertising because that's all they can do. And you're this little peep trying to say, look at me. So it's a very, very difficult, challenging thing. And so it was almost at that time, we were thinking, oh my God, are we going to make it? We took on more debt. We were able to get some debt from investors that invested in our company. We got through a really, really rough period in 2020. And now it's all changing. And now the growth is happening. The product is well positioned. We're in tier 1 pharmaceutical companies. We have global deployment. It's all really changing now, but it's been a long journey.
So just even what we're used to doing online from 2016 to 2020 is pretty different. When you started developing your product, even in the 18 months from 2017 to 2020, things had to have changed. How hard has it been to keep up with this really extraordinary database that helps researchers spend their time doing science? How do you keep up with all this behind the scenes technology up, the cloud and all of that? Is that something you personally have to manage in your company? And that way you just taking yet another thing off the scientists' shoulders, which is, great for scientists, but hard for you.
Yeah, so it's a really good question. When we started the company, we were working with technologies which I would say were kind of emerging technologies in science. So we kind of rode the crest of that technology coming into the biopharmaceutical industry, biomedical research. But as you're saying, that wave is changing while you're riding it. And so we have a technology team now that they're super great. You hire all the best tech kids you can find, and they are able to. We're constantly upgrading the technology, but we're one of the fortunate things about our product is we're in the cloud. So we're in the Microsoft Azure cloud, and the good thing about that is the cloud platform that we're on is always upgrading. So that a lot of that upgrade and that technology improvement is coming from the cloud, or it's coming from the networks that are more, accessible and available and faster. So some of the technology, we're just riding the crest of that technology wave. Of course, our team is always having to upgrade and swap out the old software for the new platforms and the new, tools that are available. So it's a constant challenge to stay current with the technologies.
So you're really focusing on, you don't have to worry about the cloud updates, but making sure that what people expect for managing their labs looks the same no matter what's going on behind the curtain.
Yeah, and one of the things that we've really benefited from is that during this period, the industry that was very, very averse to using the cloud because they felt like it was a very high-risk platform has actually moved into becoming a mainstream platform that they see that the cloud is the most cost-effective and very secure environment to work with their data. So the whole mindset of the commercial market has changed to not only accepting the cloud, but actually going after the cloud. So they're coming to us saying, we have everything on premise. We want to be in the cloud now. So that's kind of a wave that we're riding right now that's really transforming how the industry operates. And, we call it digitalization. So there's digital transformation, there's digitalization, which is part of the digital transformations. And that's what the industry right now is undergoing. And that's where, we're the new kids in town, and we have the technology platform that nobody else has yet. And we're ready to help you with your digital transformation.
So it seems to me then in some ways the pandemic made people much, much more comfortable with making that leap because they've realized for example, if everything was on one server or one computer in their lab and everybody was sent home, no one can do work, right? So has that helped you?
It has a lot because all of a sudden that's exactly it. They don't have to worry about the servers. The supply chain, if you will, that supports the cloud had no hiccups. The clouds didn't shut down, still providing the software. People could just log into the internet and get the software. And shortly after, when we realized that this pandemic was not going to be a death knell to us, which we weren't sure at first, but one of the things that happened is somebody called us up and she said, oh my God, we have our schedule on a whiteboard in our lab. And you guys have scheduling built into your software. How can we get your software? And then we had another one, and that was a customer that we have now. Was not a customer at the time, but was very interested in taking us on. Another customer that was already a customer said, oh my God, we are so excited or so happy that we've adopted your software. I am working, this was one of the scientists, she says, I'm working at home. Our technicians are in the lab because they're all gowned up. They have all their face masks on and everything. So they were working in the lab, but she was not able to go in because the offices were closed. And she said, I'm able to do my research. I'm able to work with my technicians because we have this cloud software that you're providing that allows that to happen. So I joked and said, well, we're the Zoom for this biomedical software, so like Zoom made possible all of this, that we're doing now, right, is all done on Zoom. We were making it possible for biomedical research.
I don't think you should joke about that. I think that's a solid pitch, actually, Chuck. I think that helps
explain. It is a solid pitch.
So maybe before I make you talk about something entirely different, you could describe for people who don't know how a lab works, what it is that your software does that makes it easier for the science to get done. It occurred to me as we were talking that, my long ago life, I know what's in a lab and how it works, but I imagine there are some people who don't. So as someone who's had to bridge that gap, if you don't mind just explaining that for a few minutes, that would be really helpful.
Sure. Our software works. So a lot of the work that's being done is called in vivo research, and that the work that we're involved with. And so that involves the working in the research animal rooms, the mouse rooms, if you will, all the way up to the scientist who's designing the experiments, and then through the lab technicians that are actually executing on those experiments, doing the work, as well as all of the data that are collected. So you might think of the process as going across a whole number of different personas. So you have the scientist, you have the data analyst, you have the lab manager or the study director, you have the veterinarians, you have the lab technicians, you have all of these people working together. And prior to our software, they're all using these different systems. And so when somebody needed to get the data, they would ask the technicians, where's the data? And they say, well, we put it in this folder. And then somebody would go into this folder and they would get the data, and then they forget what version of the data they had and things like that. And they would make mistakes because somebody might change the data. And there's what they call data chaos is the term that we give it. But it's there's been a lot of studies saying that the scientists were actually spending the data scientists who are trying to do the analysis at the end of the day were spending about 80% of their time wrangling data. They're really just going out trying to pull data from all these different places. So our software allows the lab technicians to be doing their work, collecting their data right in our software. They actually bring a notebook, a notepad, if you will, like an iPad or whatever, into the lab with them. It has all of the tasks that they have to do that day that have been put into the experiment by the scientists or the study directors. It has all of their tasks, has what they need to do, and gives them a place to collect the data. So basically they come in, they put their gown on, they're, cover themselves up. They go into the lab, they start doing their work, whatever it is, collecting the data, right? And the software is telling them this task needs to be done, and here's the time between each task, a very time-sensitive task. And if they're not done in this very prescripted way, the results might be different between experiments, and it's almost impossible to tease that out with spreadsheets. You don't know when people did things. This is all set up right in our software, very prescripted and very much tracked. So we know who did, the scientists and the study directors and everybody in the organization knows who did what task when and what the time differences were between tasks, so that you have a full chain of custody of who did this experiment and how it was conducted. And it's extraordinarily important for experimental reproducibility, because one of the big challenges that we were addressing with NIH is they couldn't reproduce the experiments. They would do the experiment, here's your data, and then somebody reproduce it and they come up with a different result. And it's because they didn't have tight controls over exactly what was happening every moment of time in the research lab. And without that, your science is really compromised. So the scientists can have visibility into their experiments. They can see the progress, the study directors, et cetera. They have full visibility and what we call situational awareness. They know exactly what's going on in real time in the lab, who's doing what, when, and they get the data in real time. And if there's any problem with an experiment, a lab technician can use our software to communicate directly with the scientist and say, hey, I don't know what's going on here. There's something wrong. And can be a real-time communication. And not only just a real-time communication, because you can do that on the phone, right? Or you send an email, but it's all audited within the product so that somebody coming back to check this experiment can actually see all of the work that was done, who did it, who made changes to it, what questions were asked. It's all audited within the software. And it's extremely important for biomedical research because at the end of the day, you have a drug that may go into a human. And the quality of the processes have to be extraordinarily high in order to have confidence that that compound the experiments that give us the confidence that that compound may be efficacious and safe for humans, that experiment was done correctly.
So it's an extraordinary way to show transparency in a way that we haven't had before. Or, when you were describing the technician comes in and does the steps, that's been going on in labs for years and years and years and years and years, decades, right? But not every technician would record their actions the same way. Not everyone would record it, so this is really extraordinary because I would imagine someone could take this information, not just for an audit, but to explain. For me, I look at it like this is a really great way to explain what science is, how rigorous it is, and why we can rely on what scientists tell us. I mean, that's kind of how I look at it.
Yeah, and a lot of our biggest competitor is spreadsheets and paper, believe it or not. So people
I believe you.
Capturing data on paper and then transcribing it into the computer, or they're using spreadsheets which are so unsecure. We call them the cockroaches of biomedical data because they get emailed all over the place and they reproduce and people copy them. It's such a data mess, if you will. And so having confidence in that data and then confidence in those really tight time points. So, all of the tasks for an experiment in most cases have very sensitive time components. And that's all built into our software.
All right, I'm going to do my promised switching of gears. I know you mentioned you were a musician, but I poked around a little bit, and you were a founder, right, of Acadia Tradition. So I had that right? Acadia Trad School?
Yes. Boy, you got me.
A million years ago. Well, I will say it caught my eye because it's the music that I love the most. So it was kind of easy for me to catch. So I'm just curious, number one, how you got into trad music. And number two, if you're still doing any of it to kind of get rid of stress.
Yeah, so it's a good question. I got into it just out of the love of the music. I have an Irish background, let's say. I'm American, of course, but I've been to Ireland a lot, and the music, that traditional Celtic style music, is really rooted in my cultural identity, if you will. But it's a real community music. It's a music that brings people together, helps build bridges. And so I was playing the music, doing contra dances and all of that, just got into it for the love of it, and then started actually performing semi-professionally. I've recorded a few albums, and then I really wanted to do something that was important for the community. And, using music bridges it builds so many bridges, not only between the genders, and builds bridges between the ages, it builds bridges between the cultures. So we brought together at Acadia Trad School, and this was the vision, and I'll tell you a little bit more about it, but the vision was to try to bring all these people together for a really rich week of cultural exchange within a class of music that, you can't do everything. So it was really around the Celtic roots, but this brings people from Louisiana, It brings people in from, North Carolina, from the mountains, from the Acadian lands, from Prince Edward Island, from Cape Breton, the Scottish music, from Ireland, bringing all these people together to share their music. And all of those musics are related. It turns out that they're all really a lot of the same tunes played in these different cultures. And so everybody could get together and play the same tunes and play them differently. And it just became a really great way to build bridges for the community. And that's why I did it, really, was to, help put some good energy into the universe, which really needs it. And that's the whole point of it. And to answer your question, am I still playing now? I do play a little bit now. I'm not performing anymore. I do it just for myself, but I am still involved in the traditional music. The Acadia Trad School itself stopped. We turned it into a nonprofit. It stopped last year because of COVID. And I'm going to give you a teaser. I think it's going to come back to life in a couple of years.
I'll take the teaser. This was great. Thanks a million.
Right.
Bye. The Maine Science Podcast has received support from the Maine Technology Institute and is recorded at Discovery Studios at the Maine Discovery Museum in Bangor, Maine. The Maine Science Podcast is produced and edited by me, Kate Dickerson. I received production support from Miranda Bouchard and social media support from Next Media. The Discover Maine theme is composed and performed by Nick Parker.